So the fifth application is intensity due to an infinite plane sheet of charge. This is a proper topic. Actually, this has got application in the case of a parallel plate capacitor. For deriving capacitance of a parallel plate capacitor, we require the intensity due to plane sheet of charge. So this is infinite plane sheet of charge. Infinite means, see, this is the plane sheet which has got infinite extent. So along this direction, it goes up to infinity. That plane along this vertically downward direction and towards me and away from me. So that is a plane sheet of charge of infinite extension. Infinite means when compared to the distance, this has got a very large dimensions. Or if dimensions of plate are very large compared to distance. Actually, this is true in the case of a capacitor, because between capacitor plates, the distance will be of the order of micrometer. Micrometer, which is 10 raised to minus 6 meter. And you know that the size of the capacitor is actually of the order of centimeter, which is actually 10 raised to minus 2 meter. So you compare 10 raised to minus 6 with 10 raised to minus 2. So this centimeter is 10 raised to 4 times greater. So that's a huge number. This is 10,000 10,000 times greater. It is just like 1 meter and 10,000 meter or 10 kilometer. You can compare the 1 meter with the distance between Mahi and Vadagara. So that's a very large distance compared to 1 meter. So that is the assumption which we are taking here. So it doesn't mean that the plate should be very large and infinite. Only this is actually what is meant by infinite plane sheet of charge. So in order to calculate, so this is the plane sheet of charge of infinite extent. The entire thing is not drawn here. It is indicated by the four arrow marks here. So suppose sigma is the charge per unit area. Whenever charge is distributed over an area, then uh, we will specify that charge distribution by uh, surface charge density, which is usually denoted by the symbol sigma. So this is the surface charge density sigma, which is the charge per unit area of the surface. So in order to use Gauss's theorem, we require a closed surface. So we consider a distance x on one side of the plate, a plane charge distribution, or we consider the same distance on the other side also, so that we can safely assume that field here is the same as field there, because both are equidistant, and because of the symmetry of the problem, we can assume that E is actually perpendicular to the plane sheet, and it is away from the plane sheet. So this is a Gaussian surface is a cylindrical surface of length 2s and cross-sectional area this delta A. So this delta A. So let us apply Gauss's theorem. Gauss's theorem is integral over closed surface E dot ds equal to 1 by epsilon 0 into sum of the charge enclosed by the closed surface. So this cylinder is enclosing an area delta A. So what is the charge contained inside the cylinder? That will be charge contained in the area delta A. Charge per unit area is sigma. So charge for delta A area will be sigma into delta A. So sigma into delta A is the charge enclosed by the closed surface. And we can split the LHS into three integrals. Integral on the left side E dot n ds, integral on the right side E dot n ds, and integral over the side surface E dot n ds. The integral over side surface E dot n ds will be 0. That you can see from this diagram, because E is in the horizontal direction, and whatever ds we are taking on the side surface, this n cap will be perpendicular to that. For example, if we take on the top side a small area ds, then n cap will be in the upward direction, E is in the horizontal direction, angle between them is 90 degree. So E dot n will be 0. So that integral over the side surface is 0. And what about for the first two integrals? Let us consider the integral on the right hand side. So that is this part E dot n ds. So E and n are having same direction. So E dot n is E into 1 into cos 0. So that is simply E. And we need not integrate, because this itself is a we can consider as a small area delta A. So integral will contain only integral is actually a summation of several terms, and in this case it will contain only one term, because delta A itself can be considered as a very small infinitesimal area. So you get E into 1 into cos 0 into delta A. So see that is simply E into delta A. Here also we will get same thing. E and n are having same direction. So we get E delta A plus the third one, that is 0. So that is 2E delta A on the LHS, and on the RHS sigma delta A by epsilon 0. So delta A can be cancelled, and you arrive at the result. Intensity at a distance x away from the sheet is sigma by 2 epsilon 0. So no x is seen on the RHS, so it is independent of the distance x.